Breaking news in the world of robotics and neurotechnology. Neuralink and Tesla Optimus are one step closer to a groundbreaking collaboration. Neuralink, the brain-machine interface company founded by Elon Musk, has announced new trials that bring us closer to seeing Tesla's humanoid robot Optimus, controlled by the human mind via Neuralink's N1 implant. This announcement has sent shockwaves across tech and medical communities as it blurs the lines between robotics and neuroscience. Imagine not only restoring lost physical abilities, but also enabling cybernetic superpowers that seamlessly integrate human thought with robotic functionality. Let's dive into the specifics of this monumental update and explore what the future could look like with this unprecedented partnership. Neuralink recently revealed details about its new feasibility trial, called the Convoy study, which will build on the ongoing Prime study. The trial's main focus is testing how the N1 implant can control assistive robotic limbs. This isn't just a theoretical leap, it's a real-world step toward merging human cognitive abilities with robotic precision. What is the N1 implant? The N1 implant is Neuralink's flagship brain-computer interface (BCI) device. It's a tiny chip that can read and transmit signals from the brain. Initially developed to restore communication for people with neurological impairments, the implant is now being tested for physical freedom, allowing users to control devices like robotic arms directly through thought. This is where Tesla Optimus enters the picture. Neuralink envisions a future where individuals with disabilities can use Optimus's robotic limbs as if they were their own. In July 2024, Elon Musk shared a bold vision for the Neuralink-Tesla collaboration. Speaking at a Neuralink conference, he described how people who've lost limbs could use Neuralink to control robotic arms or legs attached to Tesla Optimus. Let's say somebody has lost their arms or legs. We could actually attach an Optimus arm or Optimus legs to a Neuralink implant so that the motor commands from your brain that would go to our biological arms now go to your robot arms or legs, and you'd basically have cybernetic superpowers, Musk explained. This isn't just about restoring basic mobility. It's about transcending human limits. With Optimus limbs controlled by Neuralink, users could potentially lift heavier weights, perform intricate tasks, or achieve feats no biological limb could manage. Progress on design and movement. Tesla has been making rapid advancements with Optimus, focusing heavily on human-like movement and functionality. The robot's limbs, hands, hips, and legs, are designed with an intricate understanding of human anatomy. Optimus's hands now boast 22 degrees of freedom, DOF, making them some of the most advanced robotic hands globally. For context, human hands have 27 DOF. Competing robotic hands often max out at 6-7 DOF. This difference is huge. Jim Fan, a senior research manager at NVIDIA, has praised Optimus's hands for their tactile sensing and robustness, highlighting their ability to interact with objects repeatedly without constant maintenance. Why Optimus is perfect for Neuralink integration. Tesla's focus on natural movement and dexterity makes Optimus the ideal partner for Neuralink. The robot's ability to replicate human biomechanics allows the N1 implant to send familiar motor commands to Optimus limbs. In simpler terms, controlling Optimus's hands or legs will feel just like moving your own. Neuralink's new feasibility trial, the Convoy study, is a pivotal step in linking BCIs like the N1 implant with assistive robotic limbs. Here's what the study aims to achieve. Testing precision control. Participants will use Neuralink implants to operate investigational robotic arms. The trial will measure how effectively the N1 implant translates brain signals into motor actions. Cross-enrolling participants. The Convoy study will build on Neuralink's Prime study, allowing participants from the original trial to test these advanced applications. Restoring physical freedom. The ultimate goal is to give individuals with disabilities the ability to control robotic limbs seamlessly, restoring not just mobility, but also independence. Neuralink's announcement highlights the significance of this step. This is an important first step towards restoring not only digital freedom, but also physical freedom. Stop and think about this for a second. The Convoy study isn't just about testing robotic arms. It's about redefining what it means to be human. If Neuralink and Tesla Optimus succeed in this collaboration, the implications are staggering. For medicine, people with spinal injuries or neurodegenerative diseases could regain lost abilities. For robotics, The line between human and robot will blur, creating hybrid systems that extend human potential. For society, cybernetic enhancements could become the norm, raising ethical, legal, and social questions about human augmentation. Now let's explore where this could all lead. The integration of Neuralink with Tesla Optimus is just the beginning. Here's what we could see in the coming years as this collaboration evolves. Full-body cybernetic integration. While the current focus is on robotic arms, future developments could expand to include entire body replacements. Imagine a world where people with paralysis control fully functional robotic bodies. Soldiers wear cybernetic exoskeletons powered by Neuralink. Athletes use robotic enhancements to push human performance to new heights. This wouldn't just restore lost abilities. It could unlock capabilities we've never imagined. Enhanced cognitive abilities. Neuralink's technology isn't limited to motor control. By reading and writing brain signals, future implants could enhance cognitive functions. Faster learning. Directly uploading skills, like playing a musical instrument or speaking a new language. Memory augmentation. Storing and retrieving memories digitally, like saving files on a computer. Mind-to-mind communication. Sharing thoughts with others without speaking a word. Combining these capabilities with Tesla Optimus could lead to humanoid robots that act as extensions of our minds. Elon Musk has often emphasized the importance of making cutting-edge technology affordable. In the future, we could see mass production of Optimus robots. Tesla's expertise in scaling production means Optimus could eventually become as common as electric cars. Affordable Neuralink implants. Neuralink's mission is to democratize access to BCIs, ensuring that people from all walks of life can benefit. Imagine a world where robotic limbs or bodies aren't luxuries, but standard solutions for physical impairments. With great power comes great responsibility. As Neuralink and Tesla Optimus evolve, they'll raise profound ethical questions. Human identity. If people control robotic bodies, what does it mean to be human? Inequality. Could cybernetic enhancements create a divide between those who can afford them and those who can't? Safety. What happens if someone hacks a robotic limb or body? Governments, companies, and society will need to navigate these challenges carefully to ensure these technologies serve humanity rather than divide it. The announcement of the Convoy study marks a critical milestone in the Neuralink-Tesla Optimus collaboration. But it's just the start. As these technologies continue to evolve, they'll reshape industries, redefine human potential, and challenge our understanding of what's possible. What's next? Here's what to watch for in the coming months. Results from the Convoy study. Initial findings could pave the way for broader applications of Neuralink-controlled robotics. Advances in Optimus design. Tesla is likely to continue refining Optimus's capabilities, making it even more human-like in movement and function. New use cases. Beyond assistive devices, expect discussions about integrating Optimus into industries like healthcare, logistics, and even space exploration. The partnership between Neuralink and Tesla Optimus is more than a technological breakthrough. It's a glimpse into the future of humanity. Whether it's restoring lost abilities, enhancing human potential, or creating entirely new possibilities, this collaboration has the power to change lives on a global scale. So, what do you think? Are Neuralink and Tesla Optimus the future we've been waiting for? Or do they raise more questions than answers? Let's talk about it in the comments below. And don't forget to like, subscribe, and hit the notification bell for more updates on groundbreaking tech like this. The future is here. Let's explore it together.